In Creo Parametric 11, there are some new options for exporting formula-based lattices in STL files that were previously only available for tray assemblies. What I mean by a tray assembly, well, if I go to the File New button, I can create a new object of the type manufacturing and then choose Additive Manufacturing. When I click the OK button, here I am in a tray assembly that is used for additive manufacturing. But let me go back to my parts model. And so the options that you had previously for tray assemblies are now available in part mode, and these are for formula-based lattices. What I mean by formula-based lattices, if you go to the engineering drop-down menu and create a lattice, then you can go to the lattice type and change to formula driven. And then from the cell type tab, there are 4 different kinds of formula-based lattices that you can create: gyroid, primitive, diamond, and IWP. And I did another video on IWP lattices. This is something called a triply periodic minimal surface, like the other kinds of formula-driven lattices. But you can see an example in this parts model. And so to explain the benefits of the new options, I'm going to export an STL file with the old options. So let's go to File and then Save As, save a copy, and then let me go to my type drop-down list, which in this case is going up, and I will choose Stereolithography, STL, like I want to print this on a 3D printer. And then I can click on the Options button, and in the STL Export Profile Settings dialog box, here we have an area for lattice settings, and I will expand that. And our new options are penetration into shell, and then you can cap beams with a half sphere. And so these options are really good for beam-based lattices. Then we have this other option here for merge and blend with the shell. And this is good for these formula-based lattices. And for this first example, I'm not going to use either of these two options. For the next one, I will show you the improvements you get when you merge the lattice with the shell. But anyhow, again, I went to these different options. I'm not actually going to change anything. And let's create our STL file. I will call this the original file name with no merge in there so I can show you the result. And then I will click on the OK button. And now it's exporting. Let's give this a moment. All right, so that indeed took a few seconds to export. And now on the screen, you can see a preview of the STL that would be generated. And you can see, a little bit of stuff in here, and you can see that there's not really too much interaction between what we have for where the formulas would be generated, or excuse me, the formula-based lattices would be generated, and the outside shell. Let me hit the repaint button. I'm going to import that into another clean file so you can see the result in more detail. So let's just go to File, New Parts, or actually, let me just go to the Import button. Let's go to Get Data. Wait, sorry about File, Open. I'm just going to open the STL file. Let's do this the easy way. File, Open, and then let's find STL in here. There it is right near the bottom. And so here's the one that I just created. I'll click on the Import button, and I'm not going to generate a log file for this one. I like to use my default templates. I'll leave the automatic option. Now let's click the OK button. And so now we're importing the STL. Let's give this a moment. Okay, so I imported the STL. Let's zoom in a little bit. And what will help is if I go to a front view from my model. And so now we can zoom in and we can see that we have some gaps between the actual lattice feature and the shell that was in there. So this isn't good. You would not want to 3D print this. On the sides, it's not so bad, but where I have the curved surface, we are definitely getting some gaps in there. So that is not great. Hope I'm not zooming in and zooming out too much for you. And so now let's go back to that previous part model. and export using one of the new options. So I will go to File, Save As, Save a Copy, and then let's change our type to Stereolithography. And this time I will use Merge in the name of the file. Let me go to the Options button. Let's expand lattice settings. And I'm going to choose to merge the lattice and the shell. And here we have the blending intensity, and we have a slider bar that we can use to increase this. And let's use a value of medium for merging between our lattice and the actual outside, the solid sort of like prismatic geometry. And so now I will click the OK button and then click OK. And once more, let's give this a few seconds to generate. Okay, the STL file has been generated, and we see a whole bunch of red in this situation. Let me rotate the model, and you can see that we're getting even more tessellation in the solid part more than we did before, and it's really hard to see what we have going on at the different locations. So, like before, let me just hit the repaint button, and now let's try opening up that STL file. I will click on the Open button, and here is the one that we just generated. Let me choose the Import button, and we will select everything in here. Everything in here is good. Let's click the OK button and give it a few seconds. All right, it has been imported. Let me zoom in a little bit, and we can see that we have merging. We can see a lot more detail in the curved shell down at the bottom. Just like before, let me switch over to a front view. And let's zoom in where we had gaps before, and now we do not have gaps. We see some nice merging between our lattice and the shell around the outside. And so I would be confident 3D printing this, and I would know that I would not have any of those gaps. I'd have nice continuity between the lattice and the more prismatic geometry that is created. And so there you have it. You have these new options in part mode for exporting your lattices via STL files.